So we have this definition right here. The limit of delta x approaching 0 of f of x plus delta x minus f of x over delta x. And before we get into any theory related to this, we're going to do some calculations. So I'm going to start with this example here where f of x is equal to 4, and we're going to calculate the derivative. Now, symbolically, the way we represent the derivative is by putting a little tick on that function. So that means we're finding the derivative of f, and we're going to use our derivative definition. The limit is delta x approaches 0 over delta x. So I'm going to figure out this part right here, f of x plus delta x. What I'm supposed to do is I'm supposed to take x plus delta x and substitute it in for x, but there are no x's in this equation. So I don't need to substitute it, and I just get 4. Then I want to figure out this part, f of x, and f of x is just 4. So this is minus 4 over delta x. And I have the limit as delta x approaches 0 of 4 minus 4, that's 0 over delta x. Is 0 over delta x is 0, and the limit of a constant is that constant. So we have the derivative of f of x is 0. I went ahead and I put that answer there with the proper notation. You can see the f, the prime, we call it prime, f prime. So then I have another one here that we'll work on. Let me ask any questions about that first example. Okay, go ahead with your question. So when you find f of something, So like if I had f of x equaling 2x plus 5, and I said find f of 1, you would take that 1 and you would substitute it in for the x to do the calculation. For this example, our function is just 4. Get out is always 4. So even though this said f of x plus delta x, the answer is always 4 when you substitute it in. So that's how I got this 4, and that's how I got this 4 here. So the one on top is not f of something. For this example, our f is 4. So the one on the top is f of something, so that became the 4. But the one on the bottom doesn't have the f, so it's just delta x. Okay, let's take a look at the next example. The next example we have y equals 2 minus 3/5 x, and I want to calculate the derivative with the definition. And on each one of these problems, I'm going to be using different symbols that represent the derivative, so you can get used to these different notations. So this derivative, dy dx, this is another symbol for derivative. And the d for derivative, in the top, we have derivative of y. And then on the bottom, we see what variable is used in the equation. So the top is representing what we're taking the derivative of, and then the bottom is referencing what variable is used in that equation. So to find this derivative, we'll follow the definition, and where we do the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And we want to substitute in x plus delta x everywhere we see an x. So this becomes the limit as delta x approaches 0 of 2 minus 3/5 times x plus delta x minus, so here we're doing f of x, and this is already f of 3/5 x. And notice that I, as delta x, distribute this negative 3/5, and I also want to distribute this negative. That's going to give me 2 plus 3/5 x. This is the limit as delta x approaches 0. And we've got some things that are going to cancel out here. We have a plus 2 and a minus 2, a minus 3/5 x and a plus 3/5 x. So all that's left is negative 3/5 delta x over delta x. If we were to do direct substitution right now, we would have negative 3/5 times 0 over 0. And that would give us our indeterminate form of 0 over 0. But we're going to cancel out those delta x's and now have the limit as delta x approaches 0 of negative 3x, that the derivative dy is negative 3/5. Any questions?
Easier.
example. We're going to work on this one here. Okay, if you have a question, let me know in the chat. The notation for derivative, there are all different kinds of notations, all different types of ways to write it. And I'm trying to go through all the different ways that you can write derivative. And so we've got the first way we did it, which is here, was just to write a prime on the function. So that represents derivative of f. And then another way to write derivative is dy over dx. So on the top part, the dy, y is the name of the equation that we're finding the derivative of. So that was, this y is sort of like the name of that equation. So we're doing the derivative of y. And then in the bottom is a reference to the variable that's used here. So if I were to give you an equation y equals 2 minus 3/5 t, we would write dy dt to find the derivative. Okay, and then for canceling, I canceled the delta x's out, but the negative 3/5 carried down. And over here, I was doing direct substitution to try to find the limit, but I got 0 over 0. Anytime we get 0 over 0, that means we can simplify our expression and then try direct substitution again. So I was able to cancel out those delta x's because there's a common factor. And then the limit here, because this is a constant, there was nowhere for me to plug in that 0 to, so that limit is just that constant. Does that clarify, Bianca, or is there a different step you're referring to? Okay, no problem. Okay, let's work on another example. So this time I've got y equals x squared minus 3x plus 1. And I want to find the derivative, and this time I'm going to use another set of symbols to represent derivative, and that is to put the prime just like we did on f. So we'll use our definition, the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So to calculate this portion of it, we need to take what's inside the parentheses and replace every x with that. So that would give us the limit as delta x approaches 0 of x plus delta x squared minus 3 times x plus delta x plus 1. And then to work out this part, we need to subtract f of x, and this equation, this whole equation is our f of x. And I want to subtract the put parentheses all over delta x. With how this is written. So that is the definition of derivative that we have up here. So we're practicing calculating the definition of the derivative. No problem. Okay, so anyone have questions about how this is written? Okay, go ahead with your question.
Oh, wait a minute.
I'm not sure what you mean by that. Distributed different.
Oh, wait a minute. Oops, that's a 3. I see what I did. Oops. Okay, I think I see what I did. I see what I did. Okay.
I'm not quite understanding your question. Okay, so maybe I can try to be more clear. So we're following this definition, which is the definition for a derivative. Inside the limit, we have something called the difference quotient, and the f of x plus delta x is a calculation that we're doing. So that's this part right here. That's f of x plus delta x. Everywhere we see an x, we substitute in x plus delta x. And then we have minus f of x. That's this part right here. Over delta x. So I'm just following this definition right here with how I do it. So this portion is we substitute x plus delta x in for x, then we subtract f of x, and then we divide by delta x. So with function notation, if I give you and I say to do f of -1, you're going to take what's inside the parenthesis position.
Okay.
Negative x, you still take whatever's in the parentheses and you put it in the x position. That's 2 times negative x plus 5. So in this example up here, that's how the equation is written. I put the x plus delta in the x position. And that's why it was at the end. But on this one, the x position. So I'm changing out, basically I'm erasing this x, And in that spot, I'm putting x plus delta x. And I did the same thing up here. I'm erasing that spot, and I'm putting in an x plus delta x in that spot. Are you guys following me?
Oh, shit. Damn it. Damn it.
Okay, let's do some more practice. It's all focused on this calculation minus the you don't since we don't have the limit in pre-calculus, we practice doing this calculation right here, which is called the difference quotient. So I have a video on that I can post for you guys if you want some extra practice there. Okay, so let's continue. We've got the limit as delta x approaches 0, and to simplify this, we have to multiply out this part, use a distributive, and use a distributive property on this part. So we get x plus delta x times x plus delta x minus 3x minus 3 delta x plus 1 minus x squared plus 3x minus 1 over delta x. And then I need to multiply out these two binomials. That becomes squared plus delta x, delta x plus x delta x. And then down the way, we've got this minus 3x and plus 3x that cancels, plus 1 minus 1. So we're left with minus 3 delta x minus x squared over delta x. We have the limit as delta x approaches 0. Something I didn't do delta x times delta x, so there should be in here a plus delta x. We have x delta x. Sorry, these two terms are like terms, and they'll combine to be 2x delta x squared minus 3 delta x over delta x. And you can see that if I were to do direct substitute now, there are delta x's in the numerator, so you'd get 0 in the numerator, and delta x in the denominator, so you'd get 0 in the denominator. So what we're going to do is we're going to cancel out, you can cancel out this delta x with this delta x, one of these with this, and one of these with this. So you're going to be left with the limit as delta x approaches 0 of 2x plus delta x minus 3. And now you can do direct substitution and get 2x plus 0 minus 3, which is 2x minus 3. Any questions on any of these steps? So I went ahead and I put numbers by the steps so you can tell me which step you have a question on, and it would be helpful if you say 1 to 2, 2 to 3, 3 to 4, something like that, so I can. Right, so if you think of x, right, it's the limit as delta x approaches in for delta x. Okay. Any other questions? Okay, so just to summarize on this example, we were given y equals x plus 1, and we found the derivative y prime to be 2x3. So that's what we found in this example. Okay, so I'm going to run out of time if I do this next one, but this, so I'm going to skip it. Is done very similar to what we just did. It just takes a little bit longer to do because you have to do x plus delta x cubed, which is x plus delta x plus delta x times x plus delta x. So the multiplying gets a little bit cumbersome. So I'll leave that for you guys to practice, and that comes up 3x squared minus 3x. And I'll show you the notation. This time we have f of x equals x cubed minus 3x. And the notation for the derivative on this one looks like this. So you're taking the derivative of this. This is the name of the function that we have here. And just like in that other one, the bottom part here refers to whatever is in the equation. So this is another way to write derivative, and the derivative in this is 3x squared minus, actually that should be minus 3, not 3x. Okay. Any questions? I know I didn't do the derivative part. I'm going to leave that for you to practice, but any questions on the notation? Okay, so let's take a look at this one. So on this one, I have y equals square root x minus 3. I'm going to find the derivative, and I'm using another notation, capital D for derivative. And with this notation, the D stands for derivative. You're taking the derivative of y. That's the name of your function. And then down here as a subscript, they write the variable in the derivative of. So we're going to use our definition, which is the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So everywhere we see an x plus everywhere we see an x, we're going to change it to x plus delta x. Give me the limit as delta x approaches 0 of square root x plus delta x is square root of x plus 3 over delta x. Written. Okay, so then we'll continue on. And if we were to try direct substitution right now, we would get square root of x plus 0 minus 3 minus square root of x minus 3 over 0. And that's square root of x minus 3 minus square root of x minus 3 over 0. That's 0 over 0. I did have a question. What's your question? Okay, no problem. So when we get that 0 over 0, that's an indication that we can do some simplification. So we practiced with this type of problem in chapter 2. This has got radicals in it. Anybody remember the strategy that we used for finding these limits with radicals?
Take conjugate.
Yeah, multiply by the conjugate. So we're going to multiply by the conjugate of this radical, which is, it just has the opposite sign. And we're going to do the same thing on the numerator and denominator. So in the denominator, we're going to leave it in the factored form. And in the numerator, we're going to multiply everything out. So when we multiply the first two together, that's the same radical. Then we're going to do the outside two. So the outside two are plus square root x plus delta x minus 3 times square root x minus 3. Then we'll multiply the inside two together. And that's going to give me a minus square root of x minus 3 times square root of x plus delta x minus 3. And then we're going to multiply the last two together. So the last two, this one and this one, that's a negative and a positive, so it'll be a negative. Those are the exact same radical. Square root x minus 3 times square root of x minus 3 will be x minus 3. And I put it in parentheses because I want the minus to apply to the whole thing. Any questions about that multiplication? Okay, so a bunch of stuff cancels out now. We've got, I'm sorry, let me do the distributive property first. We're going to do distributive property here. And we can also go ahead and cancel these two terms out because one of them is plus and one of them is minus. Property on the end gives me minus x plus 3. X and a minus 3 and a plus 3 on the top. Delta x times this bottom. And then the delta x cancels out. Over square root x plus delta x minus 3 plus square root x minus 3. And we can do our direct substitution and get 1 over square root x plus 0 minus x minus 3. Root x minus 3. The same, we can combine like terms to get. Okay, go ahead with your question. Okay, and just to summarize here, we had our function y equals square root x minus. We found our derivative to be 1 over 2 square root x minus 3. And if anyone has trouble asking the questions in the chat, you're welcome to use the microphone. It's up to you guys if you feel comfortable. For the, we have f of x equals x plus 3 over x. And we're going to find the derivative. And that's the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And we're going to do the limit as delta x approaches 0. See an x, we're going to change it to x plus delta x. And that's going to be x plus delta x minus 3 over x plus delta x. Then we want to subtract our f of x function, that's minus x plus 3 over x. And that's all over delta x. As delta x approaches 0 and some stuff is canceling out, well, we'll do the distributive property first. So that would give me x plus delta x minus 3 over x plus delta x. And I have a mistake here. Let me correct it. This should be a plus, and this is a plus. That's minus x minus 3 over x over delta x. And now some stuff cancels out. We have a plus x and a minus. So I have the limit as delta x approaches 0 of delta x plus 3 over x plus delta x minus 3 over x over delta x. There is some simplification that we can do on this. And we've seen problems like this in chapter 2 before. What strategy do we take with complex fractions like this? Multiply by the common denominator. So let me read the problem. And we're going to multiply by a fraction, and we create what we're going to multiply by doing the common denominator between these little fractions. And to get that common denominator, we just multiply them together. So that's x plus delta x times x, and we do that same thing on both the top and on the bottom. So we're going to multiply that by every term. In the denominator, we're going to leave it in factored form because we're hoping something cancels out. But in the numerator, we'll do that distributive property. So we have delta x times x plus delta x times x. That's for the first term. For the next term, the x plus delta x cancels out, and we're left with 3x. And on the next term, the x's cancel out, and we're left with minus 3 times x plus delta x. So we'll do a little simplifying on the top. I'm going to leave this as it is. There's no need because once I substitute that 0 in, all of that's going to go away later. So I'm not simplifying that part. But I am going to simplify this -3 being distributed. That's plus 3x minus 3x minus 3 delta x. And we have the limit as delta x approaches 0 of delta x times x plus delta x times x. This plus 3x and minus 3x cancel each other out. Okay, and then I'll do a little bit of canceling. Maybe if I separate it into two fractions, clear delta x times x plus delta x times x over delta x times x plus delta x, x minus 3 delta x over all of this. I broke, on that step, I broke it up into two fractions, this fraction and this fraction. Now, all of this cancels to become 1. And over here, the delta x cancels. And you have minus 3 over x plus x plus delta x. Sorry, I forgot to do the substitution. So delta x is 0. And that's 1 minus 3 over x times x. 1 minus 3 over x squared. Anyone have questions or need details on any step there? So to summarize, we have f of x equals x plus 3 over x, and the derivative is 1 minus 3 over x squared. Okay, I didn't get any questions on that part. Yes, I'm going to get into that right now. So, definition of the derivative. The calculation is very time consuming. So, the rest of chapter 3 is learning a bunch of shortcuts for finding what the derivative is, because we're going to need the derivative only in this chapter, but going forward, pretty much every chapter you do in Calc 1, Calc 2, Calc 3 requires you to know how to very quickly find the derivative. You are going to learn shortcuts for finding the derivative, but that requires you to memorize a bunch of rules the next couple weeks. And the things that we found the derivative of today are very basic things. an x squared, a radical, a fraction. And you can see even with these simple expressions, it took a lot to calculate the derivative. So if we were going to get into things that look more complicated, it would take even longer. And so that's why we're going to introduce these shortcuts to find the derivative. But before we do that, we need to talk about what the derivative is. The derivative is the slope of the tangent line. And I have some pictures here, but I'm going to draw them myself. On the first day of class, we talked about approximating the slope of the line. So we have some curve, and we're interested in finding the tangent line at this point here. But we need 2 points on the line to find the tangent line. Or to find the equation of a line, we need 2 points. So we choose a second point a little bit further down. So we have x, and then a little bit more than x. So a little bit more than x is x plus delta x. These points have y values, f of x, and f of x plus delta x. And then we're able to calculate the slope of the line that connects these 2 points. So using the slope formula, we're finding the slope of the secant line. That's f of x plus delta x. That's this y value minus this y value.
Oh. Oh. Uh, Hold on, I must. Huh.
Function x squared, that of the function, and parallel to the given line 2x minus y plus 1 equals to 0. Using the limit definition of derivative, we can find out the derivative of our function. It's going to be time of x is going to be 2x. Okay, and because the slope of the given line is 2, minus 2, we can say that the derivative of the function is equal to the slope, and we can find out our x, which is 1. Right? Now, in order to find out the equation which is tangent, just parallel to the given line, we have to use the slope intercept form. We have y minus y1 equals m times x minus x1.
The slope of this line 4 is
What we have here is y minus 1 equals minus 2 times x minus x. We find out which is 1. We can solve out for y. Y is equal to 2x minus 1. This is our tangent line. Okay, and using the tangent line, we can find out our y value. By plugging in our x value into this equation. So since our x is equal to 1, we can say y is equal to 2 times 1 minus 1, which is going to be 2 minus 1 is 1. Therefore, the tangent line is
me reread.
Graph of the function and parallel to the given line 2x minus y plus 1 equals to 0. Using the limit definition of derivative, we can find out the derivative of our function, which is going to be prime of x is going to be 2x. Okay, and because the slope of the given line is 2, this line is 2, we can say that the derivative of the function is equal to the slope, and we can find out our x, which is 1.
So now it's 4. Two.
Right? Now, in order to find out the equation which is tangent, just parallel to the given line, we have to use slope-intercept form. We have y minus y1 equals m times x minus x1. Okay, what we have here is y minus 1 equals our m is 2 times x minus x. We find out which is 1. We can solve out for y is equal to 2x minus 1. This is our tangent line. Okay, and using the tangent line, we can find out our
So go. Okay. Yeah. It's cute. The slope is 3. Okay, so the slope is 3. Yes. Wait a minute. What? Page on a line that is tangent to the graph on path and parallel to the given line. Number 2. Small insect and large. So, wait a minute. This is the parallel. So, this one's the smaller. Wait a minute. Let me go back. This is confusing me. Really confusing. Go back to here. Wait a minute, where did I get 3x squared? Is that okay? Gotcha. That's right. Hold on. Okay. Is that a teacher? Oh, small. Okay. Um, oops. Go on to next. Oops. And for delta x. So
We have given the limit of f prime of c for the function f and the value of c. We have to find out what is the function f and what is the value of c. So to do that, to find that, what we are going to do is basically we write down the formula that this is in. Limit of delta x approaching 0 f of x minus f of c over delta x. Okay, if you look at this, this is our f of x. So our f, the function is 5 minus 3 times x. And the c value, if you look at it, this is f of c. We need something here that can give us 2 after going through this function. So 5 minus 3 times what gives us 2? Let's see. 5 minus 3 times 1, perhaps. 3 times 1 is 3 minus 5. This gives us 2. So exactly, our c value is 1.
hold on.
We have given the limit of f prime of c for the function f and the value of c. We have to find out what is the function f and what is the value of c. So to do that, to find that, what we are going to do is basically we write down the formula
So the
that this is in.
x is going to be
Limit of delta x approaching 0 f of x minus f of c over delta x. Okay, if you look at this, this is our f of x. So our f, the function is 5 minus 3 times x. And the c value, if you look at it, this is f of c. We need something here that can give us 2 after going through this function. So 5 minus 3 times what gives us 2? Let's see. 5 minus 3 times 1, perhaps. 3 times 1 is 3 minus 5. This gives us 2. So exactly, our c value is 1.
Oh. So gives us 9 minus 6 times x Okay, so this. What? So 1. I think it's going to be 1. Right? Yeah. Oh, okay. Oh, okay. Look at all these problems. It's just like that. X and then um, what's wrong? Did I just pass by? I did that. Hold on. Okay, so then the last one. Find the equations of the two tangent lines of the graph of f that passes through the indicated point f of x equals 2x minus x squared.
To solve this problem, we have to find the equation of two tangent lines, just given here on the graph, and that passes through indicated point 2, 5. Let us have a point, and it will be a point of tangency of the graph. We call it x0, y0. Using the definition of limit, we can find out what f prime of x is, which will be 4 minus 2x. And we can, using the points given to us, 2, 5, and the point that we came up with, x0, y0, we can find out what our slope will be. Our slope will be equal to f prime of x0, which is 4 minus 2x0.
So, okay.
And if we look at, to solve this problem, we have to find the equation of two tangent lines, just given here on the graph, and that passes through indicated 0.25. Let us have a point, and it will be a point of tangency of the graph. We call it x0, y0. Using the definition of limit, we can find out what f prime of x is, which will be 4 minus 2x. And we can, using the points given to us, 2, 5, and the point that we came up with, x0, y0, we can find out what our slope will be. Our slope will be equal to f prime of x0, which is 4 minus 2x0. Okay? And if we look at this, this is actual line, actual problem, y equal to 4x minus x squared. We also have to find out what is y0 will be, since we have this point here. Y is equal to 4x minus x squared. Y0 will be 4x0 minus x0 squared. All right, let's find out our slope.
Okay.
Formula for slope is y1 minus y2 over x1 minus x2 from the basic algebra. Okay, let's use our points and find out what our m is. This is y1. We have 5 minus y0 over 2 minus x0 equals to the f prime of x0, which is 4 minus 2x0. Okay, let's solve. Of this out using basic algebra, we have 5 minus y0 equals 4 minus 2x0 times 2 minus x0. Our y0 is right here for x0 minus x0 squared. We're just going to substitute it into our
no, I'm sorry.
y0 value. So we have 5 minus x0. Okay, let's solve this out using basic algebra. We have 5 minus y0 equals 4 minus 2x0.
Oops. Hold on. Oops. Let's go.
Times 2 minus x0. Our y0 is right here for x0 minus x0 squared. We're just going to substitute it into our y0 value. So we have 5 minus 4x0 minus x0 squared equals 4 minus 2x0 times 2 minus x0.
Okay, so this is okay. This.
Here we have 5 minus 4x0 plus x0 squared equals, let's distribute this. We have 8 minus 8x0 plus 2x0 squared. Okay, we have to make
2 times 2 is 4. Which That cancels out. No, it doesn't. Wait a minute.
Make this equal to 0 and combine like terms, so we can bring everything on this side to the other side. This is equal to 0, 5 minus.
Okay. Let me write those over here. Hello?
Hey, is everything all right?
Yes. All right. How's the game? Yeah. Where are you at? With it? Okay. Okay. Yes, I'm just trying to finish up my homework. All right. I'm sorry. I haven't been on. Quickly, I'm sorry. All right. Love you. Bye.
it will give me 3 minus 4x0 plus x0 squared. I'm just going to rewrite it in the right form because polynomial to the lowest, to the constant. We have x0 squared minus 4x0 plus 3. Let's FOIL this out. We have 0 equals x0 minus 3 times x0 minus 1. Our x0 values are 1 and 3. So using this, we can go back to our y0 value. Let me rewrite it up here.
Oh. And factor this out. Can we factor this out? Factors of a wait a minute. Oh shit. Hold on. Oh no. Yeah, okay. Factors a negative 4 with a sum of positive 2. I don't think we can factor. Yeah. So Let me see. Oops. That's not right. Wait a minute. Ooh. Okay, I'm a busy there. Really, I'm getting frustrated. rewrite this. And we got 1, 2. Okay, so let equation of volume equals 2 over okay, so first we take we'll take the 2x squared minus 2 and x minus 1. Yeah, times 2 minus 2x. So, oh. Plus so command terms. So we have x 2x squared minus 2. Okay. And then we can yeah, okay, so this video I don't like how they explain this. Okay. There we go. So So we have 2x minus x squared. Yeah, I mean, we don't have to write the 0, but so this can be we can factor in an x. Two minus and x equals 0, and then 2 minus x equals 0. Subtract 2 from both sides. And we get that negative, so we divide that negative. Okay. So for x equals 0, y equals 0. Okay. So x equals 0, y is 0. And y derivative two. So where's the slope? Oh, line. So we do. do they want the slope intercept form, or do they want they want the slope intercept form, y equals. Got it. Evaluate. F9. Okay, 1. Approximate the f derivative of 9. And the function f of x is x.
For this function, f of x equals x times 4 minus x, we need to find out the value when x is equal to 2. So f of 2 when x is 2.1. So we have to find out what f of 2.1 is. And we need to find out what f prime of 2 will be. So let us, using this function, let us find out what f of 2 will be. When x is 2, we replace the values of x with 2. So we have 2 times 4 minus 2. 4 minus 2 gives me 2 times 2 is 4. Therefore, the
You. Three minus two is 1. Okay.
the value of 4, f of 2 is
Oh.
4. F of 2.1, we replace the value of x, which is 2.1
Okay.
in this case. So 2.1 times 4 minus 2.1. If you solve this out, we get 3.99.
Mine's different. Okay.
Therefore, the value of f of 2.1 is 3.99. Let us find out what f prime of 2 will be. We can use the value of f of 2 and 2.1 in order to find out the approximated value of f prime of 2. So the approximated value of f prime of 2 is...
Oh, wait a minute. Oh, shit. Damn it. Ah, crapper. I have plugged in. Damn it, I gotta redo that. Oh, whoops. Okay. Oops. Three. And F of 9.1. Whoops. Negative.
is 3.99 minus 4 over 2.1 minus 2. If we solve this out, we get negative 0.1. Therefore, the exact value of f prime of 2 is...
Okay, so okay, so to the y value. Over Wait a minute. Oh, what the hell?
Is 0. For this function, f of x equals x times 4 minus x, we need to find out the value when x is equal to 2, so f of 2. When x is 2.1, so we have to find out what f of 2.1 is. And we need to find out what f prime of 2 will be. So let us, using this function, let us find out what f of 2 will be. When x is 2, we replace the values of x with 2, so we have 2 times 4 minus 2. 4 minus 2 gives me 2 times 2 is 4. Therefore, the value of f of 2 is 4. F of 2.1, we replace the value of x, which is 2.1 in this case. So 2.1 times 4 minus 2.1. To solve this out, we get 3.99. Therefore, the value of f of 2.1 is 3.99. Let us find out what f prime of 2 will be. We can use the value of f of 2 and 2.1 in order to find out the approximated value of f prime of 2. So the approximated value of f prime of 2 is 3.99 minus 4 over 2.1 minus 2. If we solve this out, we get negative 0.1. Therefore, the exact value of f prime of 2 is 0.
Okay. So mine at 15.1. Why don't you answer to 1 decimal place? Say that it should be. Oh, that's right. Okay, cool. Describe the x values at which the function is differentiable. Nine plus x and x. No. plus the negative 9 and this one seems nope. Not totally me. Oh, okay. Describe the x values of which the function is differentiable. The fuck? Darn it. Oh. Wait a minute. What? Hold on. Oh, damn it. So, okay, so we're gonna I'm thinking, hold on. Mm, hmm. Um, oh, let me do that. Hmm. What the fuck? Um, could, I don't understand what. Because it was the same. What the fuck? I don't get that. Oh. But, oh. Okay, I get it. Mhm. So, let me just decide. So, oh. So x can't be -9 or not. Damn it. Yep. Consider the following function. What the hell? So f of x equals absolute value of x minus 2.
For this problem, we have to find the derivative from left and right-hand side where x is equal to 0. We also have to find out if this function is differentiable at this given point. Okay, let's solve the problem. The first step, let's find out the derivative from left and right-hand side. In order to do that, we have to use the alternative form of derivative, which is f prime of c equals limit x approaching c f of x minus f of c over x minus c. Yeah, let's find out our value of limit when x is approaching from left-hand side. Approaching 1 from left-hand side. So we have x is approaching 1 from left-hand side of f of x minus f of 1 over x minus 1. Let's find out what our f of 1 will be. F of 1, with this given function, we have absolute value of x, which
So we plug
is 1 minus 1 absolute value. This gives us 0. 1 minus 1 is 0. Absolute value of 0 is 0. Therefore, our f of
oh, okay. So we plug 2 into x.
one is 0. So we have function f of x is absolute value of x minus 1 minus 0 over x minus 1. We can cancel this out. X minus 1 cancels out each other and we're left with 1. However, since our x is approaching 1 from left-hand side, where on quadrant plane, left-hand side is always negative, our limit here, left-hand side will be negative as well. Okay? Now let's find out limit from right-hand side. Limit x is approaching 1 from right-hand side. We have f of x minus f of 1 over x minus 1 equals f of 1 is still 0. Function absolute value of x minus 1 minus 0 or x minus 1. Again, we can get
It would be the same thing. Oops.
cancel this out and we have 1. Since this is approaching from right-hand side, which is a positive quadrant plane, our limit for this function will be positive 1. Okay. Now, let's find out if this function is differentiable as a given value, right?
Is the function differentiable at x equal to?
X is equal to 1. If you look at the limits of this function here, one-sided limits are not equal. therefore the function is not differentiable at x equals to 1.
Okay. Okay, so since they're not equal, so it's not. Okay.